Hello and welcome to this introduction to OpenCrowbar from the building and admin for development and test perspective. I'm Rob Hirschfeld. I'm going to give you a quick tour. This video is useful to actually go through the process of setting up an OpenCrowbar admin server on your laptop or in a lab using the Docker configuration. And so what we have here, this is just OpenCrowbar's GitHub. Has a friendly README page. We've been working really hard on improving the documentation, and throughout this I'm going to help highlight some of the places where OpenCrowbar is really different than Crowbar 1 and some of the things that we want you to pay attention to and understand and how things work. And then there's a second video where I'll really go through the operation and give you a tour of OpenCrowbar itself from the UI perspective. The thing that I'm focused on right now is building and using our development environment. So we've spent a lot of time improving and simplifying the process, and the number one thing about this is our Docker admin node. So over on this screen, what I want to do is start. I have Docker installed. Give you my version right now. I'm running on the 9.1, and there's some specific configuration things that we recommend as far as how Docker is configured, and you can go through that. And what we've done is we've actually built a Docker image that has a lot of the prerequisites installed for Crowbar, and so that makes it very fast and easy to get things running. I have the Crowbar code checked out right now. I'm doing this all using our GitHub clone code, but we actually have RPMs, and there are RPM instructions that you can follow to work through these if you don't want to do your own build or work from the code base. Both perfectly adequate. Code base is going to make it a little bit easier to stay up to date. And the way the Docker admin works, I'm going to start that process so I can show you, is we have a set of tools, something called Docker admin. You can do different operating systems. We predominantly test. I'm using Ubuntu as my development environment. We predominantly test the admin install using CentOS. The actual environment that I want to run is production, so I'm going to run the production script, and for that I have to tell it the name of my admin server. And what we've done with Docker here is we've created a pristine, prepped Crowbar environment, which includes Postgres and Ruby 2, Rails gems, some things like that the normal install will just walk you through installing, but since they're prepped in Docker, I don't have to redo it. But we didn't install Crowbar in the container. We're actually doing a full clean Crowbar install here. And that means every time I run this command, if I stop the container, I wipe out everything I've done, my database, everything. And if I restart it, it's going to walk through the full install. We use Chef Solo to do the install. So there's actually a bootstrapping script in the code base under Bootstrap, and this actually has the cookbooks that we use to install Crowbar. So Crowbar has its own installation. Unlike the past, where we actually did a full effective admin node deployment, you don't have to do that anymore. When you do the admin node, it brings itself up, it brings up the web server, but it doesn't have to go through the full installation process. That allows you to set the admin network and make configuration changes before any deployment is actually done, if you want to. By using the production script, which is in the Crowbar core library down here. Here's the production script. That goes through and it'll do the install, Bootstrap, and then it calls the API to set up and register some critical values. So it really is designed to help get you moving quickly. It's very similar to what Crowbar 1 would do if you use the full production script. So where it creates a default network, it attaches the admin node to itself, and it begins the annealing process. And we'll talk about the annealing process in some detail so that you understand what's going on. In this case, we're just literally going through and building everything up. You can see we've actually built the database right here. That's what all those migrations are for. And now Once things are stable, I'm going to kick off the background threads. One of the major differences with Crowbar, OpenCrowbar, is that it actually is a multi-threaded system. It has background workers, by default 10, that do the work of all the orchestration and configuration. So first we bring up a web server, and then we bring up the 10 workers that perform the actions. And it's one of the places that we're really very different between Crowbar 1 and OpenCrowbar. And I'll pause and explain. Crowbar 2, we changed the name to be OpenCrowbar. It was part of our process of bringing the system together. We got a lot of feedback that Crowbar repos were very hard to understand. They needed special tooling. It's very hard to use Git with them. It was hard to find things. And so we really worked hard to bring all those things together. RPM builds, a much simpler Git commit process, code's all in one place in one Git repo. We did keep all the history, and the functionality for Crowbar 2 was ported over, but we really felt like it was important to start in a new repo so that we could simplify and streamline and get all the docs straight and not have that confusing. And Crowbar 1 is still under active development. SUSE is doing a lot of great work around OpenStack development on top of Crowbar 1, and so it actually gets a little confusing to have two active code streams in the same repo. So I hope that explains why we chose to make that split. It's been a really positive thing. We feel like the code changes and consolidation that we've put together we've wanted to do for a long time. At this point, the website's actually running, and I can come back over and run OpenCrowbar. And what you'll see, this is a system overview screen. It shows the system coming up. The real action here is this is the work queue, so this is the annealer, which I'll explain a little bit here and a lot more in the next demo when we bring up some additional nodes. The idea here is that this is the work that has to be done by the system, and you can see very specifically what's going on. This is the queue type view. If you look at the system deployment, this will show you the actions that are going on in the system. So the way Crowbar works is that we break all of the activities into specific roles. If you're used to chef, these are chef roles effectively, although there's a lot more roles in the system than just chef roles, because this is how we control and orchestrate what's going on. This is the admin node, and then we're literally working through, there's a dependency graph that tells us what things have to go, and we're working through the process of each one of these components getting set up on the admin server. And so it's literally building all of the operational services that are necessary. When it gets this system's already gone through some of these steps and cached them. So for example, the OS repo cache, Crowbar will take a ISO and build bootable media for that. It has a discovery image that we call Sledgehammer, and then you can install, and I'll demo that next. You can actually install CentOS or Ubuntu or other things. We have those two configured. Right now, when you add the ISOs into Crowbar, it automatically converts them into a Pixie bootable image that can then lay down the OS, and that's what we're going to walk through in the next video. But literally right now we're just going through the process of setting things up. The annealer's running, doing exactly what we'd expect it to do. So let me show you a couple things that are happening in the process. So this is my Docker container. So right now I'm inside of the container. I could Control C out of this. Actually, I'll do that. It'll stay in here until all of the green check boxes are done. Once you've hit this converge step, it's perfectly safe to interrupt it. And now I can access the Crowbar CLI and start taking action. So this is one of the nice things about working inside the container. We have the CLI all wired in, and you can take a considerable number of actions on the system right through the CLI. So you don't have to rely on the UI if something you're looking for isn't there, if you want to automate or take some extra steps. And of course the CLI is actually just a wrapper for the API, and you could course, hit things using the API also. So now that I'm here, if I wanted to work inside of this container, I can look at my logs, so that we put the logs in the place you'd expect them to be. Var log, crowbar, production log, so that's the log, and as I go through and do things in the site, navigate, it's going to accumulate log information. And so you can go and debug and troubleshoot here. Although this isn't necessarily the place you're going to be most interested in troubleshooting, especially if you're used to Crowbar 1. What you'll see is that for every action that we take, we get very specific logs. So for every node role is a very atomic, independent action. Those actions, we capture the logs for them. We don't run Chef for these actions. We actually run Chef solo. So we'll attach to the system, preload all the data, so we use attribute injection. So we inject the attributes that are necessary for that run. We execute just the run for that one role, complete the action, grab the logs, capture any outbound data, and then stage that data then into the next place. In Crowbar, we've spent a lot of time working with this attribute injection pattern. We're very excited to be able to basically pass specific data stage to stage to stage, and that means that not only can you have very finite control of how the Chef cookbooks interact, but you can actually mix and match. So we're bringing in things like Puppet alongside of Chef, so you can use them. In parallel or SSH, or add and extend your own system. So it's very easy with this type of model to extend the automation framework to have your own capabilities. And so what I'll do is I'll show briefly. I fixed that bug, so I'm a little frustrated. I just hasn't gotten through the pull request process yet. So what happens is with these individual roles, I can navigate through. I normally can navigate through and show you all the bits and pieces where the roles are tied together. Okay. So let me show you some other details about how Crowbar is going to operate as a developer. So I've showed you the logs. What I also should show you, so I'm going to jump over to the top level of the GitHub. So one of the things that we've done is, instead of having all the bar clamps, we're really trying to focus much more on workloads and versions. So Crowbar core itself, this is all the core, and you'll notice in here we still have the concept of individual bar clamps, but they're all governed together so that you don't have a spread of a whole bunch of pieces. And same is true OpenStack, Ceph, hardware, Hadoop. These different workloads are actually versioned as their own thing, and so they are maintained in their own repos. Rather than having 6 million individual bar clamps where we split everything out, we want to have things more consolidated so you could track things in a more logical way. We've been adding the concept of Berkshelf and Berkshelf pointers for some of these cookbooks, so it is actually possible to take, say, the OpenStack cookbook, the OpenStack workload, and then pull in the direct upstream cookbooks from OpenStack, and that's really been an important point for us. We don't want Crowbar to have its own cookbooks. We want to be able to fully leverage the community ones. That's partly why we adopted the attribute injection pattern. So over here, I'm using OpenCrowbar core. And if I look in this, one of the benefits of the Docker containers is that we've actually cross-mapped the code here directly into my code working environment. So this is outside of the container. This is where I've cloned out the code. So if I do a git status here, you'll see I've got my code. I was playing around a little bit by adding these files. Let me remove them, and I will recreate them. and this will hopefully make some sense. So right now, if I do this, if I look at the list there and the list here, they're going to be the same. And if I touch foo.text, you can see I'm repeating my demo over here. You'll see foo.text is included. So I'm able to transfer files back and forth between the container and my machine. That's not normal container Docker behavior. Part of our tooling when we set up the admin server is to map the present working directory, your current working directory, into OpenCrowbar core. And what that allows you to do is I can come back and I've checked out Ceph here, and so that means that Crowbar is going to also discover Ceph. Let's see, so it should, when I look at the bar clamps, I see the Ceph bar clamp. So it's a really important point in how this works. If you have checked out things as siblings to the Crowbar core, so I could bring in OpenStack, which is still in development. Ceph is actually our first workload, and we've made a lot of progress with Ceph. When I bring those things in as siblings to core, they're automatically mapped in and discovered as additional workloads for Crowbar. So Ceph is actually installed in this demo environment. Or sorry, the Ceph workload capability is installed. I haven't installed Ceph yet. The system's still brand new. So going back to core, that allows me to then make modifications on this side. So if I was going to touch bar.text and check that here, you would see that yes, you would see that I've got that file here too. The reason why that's important is the way Crowbar works is that we copy over the chef recipes or whatever deployment you use as part of the process that we use. We copy over the code along with the data on every run, which means that if I go into the cookbooks here, so into my chef cookbooks, and I start making changes for my deployment scripts as a developer to make changes I make here will be picked up immediately when I go to run the system over here. So any action taken to do annealing and run the processes, if I make a change to the cookbook, it immediately takes effect. If you're used to Crowbar 1, that's not how it worked at all. You actually had to upload new cookbooks and then reapply them. For Crowbar, for OpenCrowbar, literally all you have to do for if you want to make a change is go into the role that you wanted, and you could retry that role, and then the system is going to catch that there's a change and it'll reapply that. And very importantly, it is aware of the dependency graph, and then it automatically reapplies all of the downstream dependencies, because if you made a change, the downstream dependencies are going to be impacted. It's a really significant action here. Is that not only can I make a change, reapply it, and go through a full cycle very quickly, but Crowbar is tracking your dependency graph, and it's going to automatically be aware of what's going on with that. Okay. So some of the other things that you want to be aware of with the Docker container. So I just did a PS, so this is the container that I have running. It is possible to snapshot this container and keep it running in the background and thereby have a persistent admin node. We don't normally do that. The goal here is to just make it very easy to bring one up, test it, use the latest code, check it. If you've made changes, you can then actually, if I fix a bug, I can then push the change back through this environment, right? Because I'm now in my Git. I have full access to my Git environment. It's very important to note that I'm about to start a demo where I boot other machines using the Pixie boot process, and to do that, I'm going to need to map the Docker bridge into an Ethernet port that I can use. So, by way of looking at the setup, this is my build machine. In that machine, I have 3 network adapters. One is NATed for the internet, The other one is my host adapter, so I can talk to it, SSH, and do things like that. This third adapter is the one that we use for PXE booting. So this adapter is set up in the virtual machine as ETH2. You'll notice here's ETH2. I've already gone through the configuration process, but I'll show you what is happening. If I look at my bridge control, what you'll see is Docker. My Docker bridge has ETH2 and the interface for my container, which means that the container I'm running over here, this blue session, and ETH2 are able to communicate. So when I take this slave node and start its only adapter is this Ethernet host only adapter 2. So that adapter, when I PXE boot it, will respond. Crowbar will be able to PXE it. If I wanted to do this without virtual machines and use physical nodes, all I have to do is bind this Docker bridge to whatever Ethernet port I have available for my PXE boot environment. I could do that through any physical network, however I felt like I wanted to do it. In this case, it's super easy just to use VirtualBox as a way to boot slave nodes. We used to do this in Crowbar 1 all the time. We had a much more complex networking configuration. Crowbar 2 OpenCrowbar is much more flexible from a networking perspective. So I have to, normally I would do a sudo bridge control, add interface to Docker to ETH2, like that. That's already been done here, and then I'd also have to turn the link on, because we don't bind that IP address, we let it just be a pass-through. So I'm going to do an IP add link set ETH2 up, like that. And these steps are in the documentation, so you don't have to pull them off the video. I mention them here because they trip people up if they're not aware that they need to do it. Another thing that's important to realize is we switched Crowbar to use online mode. So in the past, you would have had to build a whole ISO, then boot a machine with that ISO, and then that would be your deploy media. Between Docker and RPMs, we don't do that. We only include the Crowbar bits in the Crowbar pieces. And so you must have internet access to use Crowbar. We're working on some caching strategies that'll make that not as necessary, but it's a significant benefit for being able to bring new things in and try new things and do different operating systems. So Crowbar will go to the internet and pull in the things and dependencies it needs in order to get the installs completed. Okay. The other thing that's worth noting is that we've been very careful to not create the documentation mess that we had created before. And so Crowbar has a documentation infrastructure. We've been spending a lot of time in the development guides, documenting the API and the model and principles, workflows. So there's actually quite a bit of information in here, and the /doc directory is the authoritative source for all Crowbar, OpenCrowbar documentation. There is no other wiki. We have other things floating. They all funnel back into here. So if you're looking for something, it should be here. If it's not, add it or talk to us and we'll help get those things added. We even have information about how the doc guides are formatted and things like that. So there's a significant amount of information for you to start with here. And of course, I'm going to recommend you start with the dev systems to actually build your pieces, and it goes through the things that we're talking about here. Okay, without further ado, I'm ready to start booting machines, which means we're ready to transition to the demo video. I will talk to you there. Thanks.